what's left here. So we left off with chapter 19 yesterday. So the simple version of defining a enum might be something like this. You say enum speed, stop, slow, normal, fast. So what we're doing with enums is we're trying to give a kind of a limited set of values that something can take, right? So we know it can only be A, B, or C. It can't be anything else. That's anytime. That's where you're going to see enums. If it's limited possible selections, and they're never going to change, right? So if the user has the ability to change any of these things, then they're not a good candidate. Then we're better off using a list or using a database. But this is if I know for sure here are the values, they'll never change. Okay. Now I can simply specify an enum like this: stop, slow, normal, fast. Notice I'm not giving them any sort of values, right? So typically that first one will be 0, 1, 2, 3 is kind of the values that they will be assigned. Now there is a little gotcha in the sense that in C#, these enum values were all represented as ints by default, right? So this was really just a shorthand for defining an int with value 1, 2, 3, 4, right? As far as the compiler treated it, as far as runtime, it was just stored as an integer, okay? Now these are objects. These are actually full-on objects. And that means if you want to compare them, you still really need to compare them with, probably compare them equals. Although you can actually get away with enums comparing them with double equals. It's actually okay. It's actually okay. Why would that be okay? Why would it be okay to compare two enum variables with equals? Yep.
Because no matter where you use them, it would have the same memory address.
Yeah. So they're going to end up having the same memory address if they're the same thing. Yeah. Because all these enum values, these objects are only ever instantiated once. So if I say something like, I write my code, this is speed, so I've got speed x is equal to speed dot slow. Speed y is equal to speed dot slow. If I compare these two things with equals equals, it's still going to come out okay because they are actually at the same location in memory. The actual object is in the same place in memory. Okay, so you can actually compare enum values with equals, which is great. So the other thing, though, coming back to the kind of the data type, and this is where I wanted to talk about yesterday. When you're actually creating these enums, they can do a little bit more. So if I was writing these out in C#, let me make this bigger. I'll move this down a bit. So if I was writing in this in C#, let's say I've got Mario Kart, and Mario Kart's got different size vehicles, right? You got your light vehicles, you got your medium vehicles, you got your heavy vehicles. There's no other kinds of vehicles. They fall into one of those three categories. So I could say in C# light equals 1, medium equals 2, heavy equals 3. But I can't give them any additional values. I can only give them those numbers, right? So I can say this is 1 star, 2 star, 3 star, but all the other code that I want, I have to write somewhere else, right? So there may be a lot of different variables that I want to associate with a particular weight of go-kart. Okay, so I might want to say, well, and this is where Java being objects is a little bit helpful. I could say, okay, I want to associate a name and an image with that weight. So I associate a name of that image I'm going to use, acceleration modifier, top speed modifier, and weight modifier. I have all those variables in this one object, right? So that anytime I need to know these kind of things from your type, your weight class, I can just say, well, weight class dot acceleration, right? So I create a constructor, just like this is a regular class. I say, take all these things in. I'm going to save all these values here. So all of this, what I'm doing here, is just like creating a regular class. Now note, one of the important things I've done here, I've marked all of these as final. Right? I've marked them all as final so that they can't change. Because if they could change, that would be a problem. Okay. But then I've also marked them public. It's okay to mark them public because I've marked them final. Right? They can't actually change them.
So to access it, would you just say car weight dot medium dot name?
Well, I'd say I'd have my car weight in a variable, right? So I'd have I'd have something like cart weight let's just call it W for short, is equal to cart weight dot heavy. So if I'm Bowser, I'm going to have a cart weight of heavy, right? Now I can just do W dot name or W dot acceleration or W dot weight, and that will give me all of these variables, right? Which makes it really easy to look up those stats. Okay. So the way that I now define these, remember, so the important thing with defining enums in Java, you're going to split them by commas, and then the last one have to have a semicolon at the end. And also all these values have to be the first line in the enum. I can't move this anywhere else in the enum. It has to be all the way at the top. Okay. So what I'm saying is light is text light 1 star PNG to 0.25. So I'm putting all these modifiers in there. Great. Now I can access them anywhere. If I have the enum value that determines what speed, what weight class they are, I can just get all these modifiers or the image for their class. Does that make sense? Can you see where this might be helpful?
So you can kind of think of it as like a subclass type of thing, where you have your parent class and your subclasses of light, medium, and heavy.
No, because these are instances, right? So I have the cart weight class, effectively. You can think of cart weight as a class.
Oh,
and these are instances, because these are objects. Light is an object, medium, heavy is an object. They're not actually classes, they're objects, they're instances. The difference between this and a normal class is with a normal class, I can keep creating instances. I can create as many instances as I want. Here, I only get those 3 instances. There will never be more instances of cart weight. That makes sense? In a normal class, I could create as many as I want. In fact, I should probably be marking this constructor as private. Why? Oh, I'm using the wrong keyboard. That's why. Probably be marking that as private. So that limits other things being there. Another important stipulation, unlike classes, enums, these can never be derived. I can never inherit from cart weight. That's it. And because if I could, then I could add additional values to the enum if I could make a subclass. I could create additional instances of cart weight, but there's only ever those 3. Does that make sense? So that's where they are quite different, and there's a lot more you can do with enums than what you might see in C#. Also note when you're dealing with switch statements, switch statements and enums are literally made for each other. They're meant to be used together. You should totally be using them together. But with a switch statement, I can say case slow. I don't actually need to say the type. So I don't actually need to say the enum type when I'm doing these switch statements on a case. I mean, on a new value. That make sense?
Then you type the cart weight.
So here, this would be speed, right? This would be speed, or cart weight in the example we were looking at. So anytime I'm switching, I don't need to say what's the name of the type. I don't need to say speed.stop. Everywhere else, I need to say speed.stop. But here I don't need to say speed.stop. So we get into here, kind of talking about that. So they add a speed variable, and they're initializing it as 0, 5, 10, 20. So initializing that speed for different values. There's also some special functions because enums are not a subclass of objects. They're actually a subclass of enum. So in that process, because they're a subclass of Java that Lambda enum, they actually get a few useful methods. One of them is values, which will give you an array of all the values. So if I need to have those to put into a drop-down list or something of that sort, I can do that. So I can populate a drop-down list using this values method. I can also call value of, and that will take a string and turn it back into a new value. So if I had string fast from reading it from a file or reading it from a drop-down or wherever it may have come from, I can turn that back into a speed object. Does that make sense? So I can use values to get a list of all of them, and then value of to say, okay, I want to take a string and turn it back into there, back into the output. Figure out which object that is. This value of, if I remember, is case sensitive, so like lowercase stop won't work. It would have to be uppercase stop to match the case exactly. But that can be useful, again, for things like if you're storing this to a file or to a database. You may need to use value of. Okay, so exceptions. Exceptions, on the one hand, they work like you're used to. On the other hand, they don't. So as far as working with exceptions in Java, there are a few things that are different. And I gotta forewarn you that this is probably the way that Java deals with exceptions is, I think, the thing that I've heard people complain most about Java when they first learn it. Honestly, I think there's a lot of benefit into what they do, but it can be kind of a pain in the neck when you're first getting into it. Okay, so when we're dealing with exceptions, okay, every method that could throw an exception has to declare what exceptions it might throw. Okay, it has to put that into its signature. It has to say, what might it throw? So in this case, I am saying I want to use this file reader, and the constructor for file reader might throw a file not found exception. Because it might say, okay, you tried to open up a file reader to a file with this name. If it doesn't exist, it's going to throw a file not found exception. So that's not necessarily any new than C#. I can catch that. Okay, but if I don't catch that file not found exception, that was really on me in C#. It's like, oh, I goofed. Sorry, I should have caught that. Or I'm just going to choose not to catch that. Well, if I didn't catch this, say I wanted to write this, I'm going to get compile time here if I put this. In fact, let me just write this into, let me go put this in IntelliJ, because this is worth looking at. What the actual error is. Or I might just do Java C. Java C is probably just fine. New text document. This will be fileio.java. Yep. Edit that with Notepad. Okay. So in here, we make a quick change. Did I not get that? Oh, I have to type it in. Okay. So import java.io.fileReader and public class file IO. And I'm going to say public static void main string new file reader. I'm going to try to open up missing.txt. Okay. I'm going to save that file, and we're going to run that real quick here. There we go. Open PowerShell window. So I'm going to say java c file.io.java, compile it, and see, you see the error that I'm getting. So I'm saying it says unreported exception, file not found exception, must be caught or declared to be thrown. Okay. So when I called file reader could possibly throw file not found exception. But note that this is a compile time error, not a runtime error. Okay. In C#, this would have been strictly a runtime error. I wouldn't know until the program runs. But here it's actually saying at compile time, I need to check for that error. Okay. So it's giving me two options. I must either catch it or I must declare that it's going to be thrown. Okay, so the way I catch it, I just throw a try catch around it as they've shown. So if I put a try catch around it like that, catch the file not found exception, it would be happy. It would still throw an exception at runtime because that file still doesn't exist, but it wouldn't throw it at run.
So this is kind of used to kind of give a heads up to users of certain classes that these problems may arise.
Yep.
So like if I neglected to put like a throws whatever in my method signature and it throws something, that then becomes a runtime error and not a compile time. Similar to how it usually would be.
Right.
Right?
It forces you to look at as you're writing the code and potentially do something about that error before it becomes a problem in production.
Okay.
Before it gets to end users and they're running it and it happens in the field, it forces you to solve it as you're writing the code. So I could say that this method, the main method, throws a file not found exception. I could just say, I'm not going to deal with it. Let the method that calls me deal with it. Okay, so if I do that, I should be able to compile the program now. Compiles just fine because I've declared that I am going to just let it go. I'm not going to deal with that exception. But if I run the program, I'm still going to get that exception. Right? So I've not really handled the exception, as we would say. Right? I haven't really done anything to fix the problem, but I have said, hey, I'm going to throw it, let somebody else deal with it. Right? So that's one thing that's one of those things that you can do when you're working with Java. Anytime you can encounter an exception or you're calling a method that could throw an exception, you have one of two options. Either you say, I'm going to deal with it, or I'm going to throw it on to somebody else. So if you have an exception that could throw if you have a method that can throw an exception, you have to say that it will. Yes.
So how do we know what exceptions are?
So in the IDE, it's relatively easy. You right-click, go to definition. If I'm looking at it without the IDE handy, remember I showed you how to get to the Java doc, right? So Java 13 API doc. Let's go there and let's look at the file reader class, because that's what we're looking at right now. So if I go to file reader, I'm calling this constructor that takes a string. So look right here, it says throws file not found exception. So it's right in the documentation where it says what could it possibly throw. It even tells you the conditions under which it will be thrown. So it'll be thrown if this is true. Now, some exceptions we can write our code in such a way that they won't happen, right? Other exceptions, I cannot write my code really around them possibly happening. So I can't completely prevent the possibility that if I try to open a file, it might not be there. That's always a possibility. So that's one of those things that we're just going to have to catch the exception if it occurs. I can say file exists and say, let's go check if the file exists, but it's entirely possible between the time I checked that it exists and when I opened it that it disappeared because some other program deleted it. So even checking it doesn't mean that I necessarily worked around the exception. It's a good thing to check that it exists, but that won't necessarily solve all the issues. Because the other thing that could happen where you get a file not found is if you don't have access to that file. It might be there, but you, for whatever reason, aren't allowed to access it. Whether because another program has it open and locked, or because you don't have the right permissions. Okay, so that's one of those pieces. Okay, so we can write a catch block. That catch block will say what kind of exception are we going to catch, and then what to do with it. Now note that I can also have more than one catch block. So I can say if it's a file not found exception, then do this. If it's any other kind of exception, do that. Right? Now the way you want to arrange these, because the order does matter. Okay, the order does matter. It's only going to run the first catch clause that it can. It will never run more than one catch clause. Okay, so if I do these in the other order, exception and then file not found, well, every exception is an exception. So it will only run this case and it would never run that if those were reversed. Okay, so it is important that you start with this lowest subclass, the lowest child class, and then you kind of expand to parent classes from there. Okay, so we might say file not found exception, and then you see exception in there. We also have, for instance, here, if you want to say two different kinds of exceptions, do the same thing with them. I could say IO exception or SQL exception. Well, I'm going to do the same logic with those two things. And as far as what type this E variable ends up being, E would be whatever the common parent of those two things is. So for instance, between IO exception and SQL exception, the common parent is exception. So E would be of type exception. So one important thing to know is you're writing catch clauses. This right here is bad. Why is that bad? Evan?
Because it just basically acknowledges that could happen without doing anything.
Okay.
That's what I was going to say. English brackets to help anyone out.
Right. It means that if I write code like this, I don't even know the exception occurred.
Right.
I don't even know that something's wrong. That's really bad. That's really, really, really bad. We referred to that as swallowing the exception. Gobble it all up, and it's gone. Nobody knows that it even happened. You don't want to do that. I will take points off if I see you swallowing exceptions. I guarantee you that. It's that big of a deal.
If you have a catch block, you need to give it something to do.
Something to do. Okay. Even if that something to do is just write out the exception to the console. That's good enough. General good practice is if you can do something about an exception to correct it, definitely do it. But at minimum, log that the exception happened. At a minimum, log that something went wrong so that you can go back later and say, okay, I can fix it. Okay, so here we're going to do system.print and print the message of the exception. When we get into Android, I'll show you there's something called logcat, and we'll be writing the logcat there instead in our catch clauses. But effectively, that does basically the same thing as system.out.print. Does that make sense? You always want to do something with the exception. So again, most common thing is to log it. A lot of times, though, it also is worth rethrowing it. So you may have something like this, where if I say, I can't open the file, I'm probably done at that point, right? There's nothing I can do. If my entire goal, let's say my entire goal of this function was to open this file, read it into memory, read the CSV file into memory, well, if the first thing I do, I can't open it, I'm probably done. So more often than not, you also may find yourself throwing that exception once you catch it.
What's the point of that when you can just leave it without the try catch?
Because I may need to do a little bit of logic and then throw. I may need to do a little bit of cleanup or other things. I may want to log the exception and then throw it again. Things like that. Okay, I may want to do something else. Okay, so catch is how you catch an exception. The throw keyword is how you throw an exception. So if I wanted to throw a file not found exception, I would say throw new file not found exception. I always have to create an object to do that. Or in this case, I would say just throw E. I would just rethrow the same object. Okay. Also in Java, there is the finally block. You'll remember me talking about that last semester as it being kind of important. That's where we're going to do all our cleanup. So, for instance, the code that I wrote just a minute ago, like so, is kind of bad. Or like here potentially, because what we haven't done is we've never closed the reader. See that? There's nowhere in this code that we're closing the reader. Okay, so that file is effectively still open, which may mean that no other program can open it because we are in the process that we have it open, or that file can't be deleted because we're keeping it open. So it can't be deleted until your app crashes. That might be a problem. So we want to make sure that anytime we open a file that we also close it. Okay. Now historically, this has been the way to do it. Okay. So we've got up at the top here, we created a variable file reader file equals null. Okay. The reason I have to declare this outside of the try is because if I didn't declare it outside the try, I couldn't get to the file or the catch. So if I want to be able to get to this file reader in the catch or the finally, I need to have access to it. Okay. So in order to do that, I need to make sure I do that. I need to make sure it's out here. And then when I go into here, here's where I'm going to now say new. Because again, the new can throw that exception. The new can throw a file not found exception and say, hey, we didn't find the file. So we could fail right here. I can fail there, or I can fail later as I'm actually reading the contents. Okay. So if I fail in this first line, if I say if this constructor throws an exception, what state is the file variable left in? Is what? So let's say this constructor throws an exception. It'll be null. It's null. Because this line never got a chance to finish. So in fact, the constructor hopefully is smart enough to close that file if it needs to throw an exception, because otherwise I have no way of doing that. Because I've never got an actual file reader object. Because the constructor threw an exception, I never got an object. So that means that this is still null. which means when I get to finally, file is still null. If it crashed later, let's say I have more code after here that was reading the file, reading the contents of the file, and crashed in there, then file would not be null. Okay. So, and that typically you're going to have both of those things. You're going to open the file, you're going to construct the reader or the stream, and then read it. So it could fail in either way, which means that anytime we have this finally clause, we need to check whether or not it's null. Does that make sense? We can't assume that it's not null, because otherwise we'll get another exception for it being null. So we say, is it null or not? And then if it's not null, then I'm going to close the exception. Now, Java has decided historically to do something very annoying with the close method. Remember how we looked at the constructor and it says it can throw an exception? The close method can throw an exception. So I can fail to close a string, which is just bonkers. And realistically, there's no way to solve that. If you fail to close the string, what am I supposed to do? I can try to close it again. It's probably going to fail a second time.
You just hold that forward that point.
So at that point, oftentimes you'll see this. We close the exception. If there is an exception there, we just gobble it up because there's realistically nothing we can do. Does that make sense? This is bad, but unfortunately it's what we're stuck with. Because at that point it's like, okay, I can try to close it again in this catch. Well, that now could throw a file exception, so I have to wrap another layer of try catch. So if I try to close it a second time, I have three nested try catches. So it gets kind of to be a pain. So you'll see these kind of, this historically is things we had to write again and again and again and again, whether we were dealing with files or databases. So there is a newer syntax, which I would strongly advise you use, which makes this a lot easier. But historically, this is what you have to do. And if you have something with an object that's still not of the proper interface, that doesn't implement the closable interface, you still won't be able to do this. But as long as you're working something that is closable, there's a shorter syntax in this. Okay. And what we call it is it's called the try with resources statement. Okay. Try with resource statement. It looks a little funky. So try, note that I have those little parentheses. Let's see, even before I've gotten to the actual try block. Okay, so I'm going to try file reader equals new file reader. That's the resource part. Okay, this is the resource that I'm using. What happens is, as long as you can use this, as long as this object here implements the auto-closable object. I think they mentioned this here. Yep. If it implements auto-closable, you can use this structure. So what this will do is it will go ahead and build that finally clause out for you. It will say, try to construct that. If that fails, or at the end of this try, go ahead and close that. Whether something goes wrong, whether there's an exception or anything, automatically try and close the file.
Kind of like a using statement almost.
It actually is basically identical, right? Forget about the catch. Just put the word using here and it's the same thing. It's almost identical. Using and try with resources are almost identical. As far as date of origin, try finally is the thing that came originally in both languages. And then C# added the using statement, and then Java added try with resources. So they said, oh, C#, that's cool. We'll make our own version.
So there's a lot of back and forth like that.
Yeah. So this, keep that in the back of your head. This is really useful. We'll get to that if we deal with files or if we deal with databases.
Oh, no.
So that's try with resources. And you may see some errors in Android that suggest, oh, you probably should do this, because Android Studio does occasionally suggest you need to use the try with resources statement. That's what they mean. So effectively, if we're dealing with more than one file, we can also sometimes write it like this. I don't know how well this actually works. I haven't really tried this syntax to know if this actually closes things properly the way it's supposed to. But it does exist. I would say the safer thing to do is always declare a parent. But you can use more than one file if you need it with the same file. It's very rare that you need to open more than one file at the same time. Throwing exceptions, like I was mentioned earlier, if you want to throw an exception, you're going to say throw new exception type. Now, as far as Java goes, there's a whole hierarchy of exceptions and other things that you can throw. Okay, so let's look at that class hierarchy a little bit, because it's important. So in the world of Java, there is the exception class. And typically anything you catch or throw will be a subclass of that class. Okay? So the thing you need to know, though, is that that's not all that exists that can be thrown. So in Java, there's also this class called throwable. In reality, anything that can be thrown has to be a subclass of throwable, not exception. Okay, so exception is a subclass of throwable. Throwable actually can be thrown because there's another category of problems called errors. So you've got throwable as the parent class for anything that can be thrown. As far as throwable breaks, and then throwable breaks down into exceptions and errors. Okay? So exceptions are things that happen at runtime that ideally you should be able to deal with. You should do something about. Even if it just means you're logging it, but you really want to know about it, you might want to write your code around planning for those kind of exceptions. Errors are things that you can't predict, and if they happen, there's really no solution, because errors usually come down to things that are due to other programs running on the system. So an error is usually something you have no control over. Okay? So as a general rule, we never ever catch errors, nor do we throw them. Okay? But they can be thrown. Okay? So the most common kind of error is what we call a memory out of memory error. If your system doesn't have enough memory to do what you tell it to do, you will get an out of memory error. That makes sense? Because that may be caught, and it's an error because that may be caused by some other program using up all the memory. There's no memory for you. It could be caused by your program using up too much memory, but it could also be caused by somebody else, right? And more than likely, even if it is your program, you probably can't do anything at the cache where you're at to fix that. Does that make sense? If you have a memory leak, if you're using up way more memory than you're supposed to, where you get out of memory, you run out of memory, then there's really nothing you can do. Does that make sense? So errors we don't catch. And we don't have to declare that our methods might throw it, right? So you saw that throws clause that you have to add at the end of the method signature if you might throw an error. We don't add those. If an out of memory might occur, we don't declare that that might occur. Because again, errors are really outside of our control. Okay. Exception breaks down further. So exceptions break down into like runtime exception is a very special class of exceptions. There's also a very common one called file I/O exceptions. Under file I/O exceptions, actually, no, sorry, it's just I/O exception. Under I/O exception, there's also, for instance, that would be where you would find file not found. So if you have a general I/O exception clause, that will also catch file not found exceptions. Usually that's the only catch we have. We just catch all the I/O exceptions and treat them the same. But that's worth knowing. Sometimes you can reduce the amount of code you have, the amount of exceptions you have to catch by using a parent class. That makes sense? So I/O exceptions, file not found exceptions, anything over here that's not a runtime exception, we have to declare that our function throws. Okay, that's where we have to declare that it's thrown as considered checked. Okay. Runtime errors and runtime exceptions and errors are unchecked exceptions. We don't have to declare that our function might throw them. Okay. The reason is most runtime exceptions can be avoided by just writing good code. Does that make sense? Most runtime exceptions can be avoided by just writing good code. Okay. So what are common things that might happen over here in the side of runtime exceptions? What are common things that you might goof up that happen really often?
Accidentally setting a variable in division to 0.
Yep, so divide by 0. There's actually a specific example. There is one here. Divide by 0. I can't remember if it's actually called what the name of that exception offhand is, but that falls into as a runtime exception. So if I'm dividing, I don't have to declare that I might throw an exception.
Well, I think if you use constants and divide by 0, it'll create a syntax error.
Yeah. It'll do it at a compile time. Yep. So null also fits in here. So null reference exceptions fit into there. So those kind of things are dealt with. Basically, if I had to declare that my function might throw this, then I have to declare that anytime I do division. Or I'd have to catch it anytime I do division. That would be a big burden. Or if I had to declare null reference exception, well then every single method in your code would declare null reference exception. Because pretty much any code that you write will work with objects and therefore can throw null reference exception. So both of these things are considered runtime exceptions. There's a whole big category of that. And those are things we don't have to declare that our code may throw. In fact, that's a very useful thing to know because, and I have run into this specifically, sometimes there are cases where you need to create your own special kind of exception and you want that behavior for your own exception. I can create another subclass of runtime exception and then it has that behavior being unchecked. Because there are cases where that does happen, where you need your own special kind of exception, but you also don't want to pollute your code with try catches because it's something you can easily work around, easily prevent. Array out of bounds also falls into this runtime exception case because most array out of bounds exceptions, you know what size the array is. You could have just written your code so it didn't get that. So that falls into there. And if we specifically want to look at all those subclasses, let's go back to the Java doc and I can look at runtime exception. So it's in the lang folder. Direct known subclasses. This very, very long list of classes, those are all subclasses of the runtime exception. Note that there's a very long list. So there's a lot of things that fit into that category. Okay. So like index out of bounds, that's if you're trying to access an array index that you don't have access to. There's also things like a legal argument exception, a legal state exception. So there's a lot of things in here that you can throw. It would be worth your time to go peruse this list and look at some of those, because obviously there's a lot of ones in here you won't see, but a lot of the common ones in here are really good to know about. Okay. Any other questions on exceptions there? The biggest thing to understand is if your method might throw an exception, you have to declare throws exception and tell it what kinds of exception it's going to throw. So in here, if it's more than one kind, we say throws IO exception, arithmetic exception, to say it could throw either of those two things. And as you're looking through the documentation, you'll see that in the documentation where it will tell you what exceptions it could possibly throw. Okay. Now, boxing and unboxing. This is where we get to the weird world of Java. And I mean weird world of Java, because only Java will do this way. So boxing and unboxing, this idea largely came out with Java 5 when generics were introduced. So generics is, go figure, chapter 22, so we'll get to that in a minute. But suffice to say, the thing you need to know about generics right now is that it only works with objects. It doesn't work with primitives. So in C#, I could do a list of ints, or I could do a list of bools, or I could do a list of employees. I could do a list of anything, because generics works with any type. Okay? Make sense? Okay. The reason that worked is because when things actually run in C, I have the idea of having the generics are still preserved at runtime. Okay. The way that the generics compilation process works with Java is the generics are actually compiled out. So there are generics as you're writing your code, but when the code actually runs, the generics are removed. So you'll get syntax errors and compile time errors when you're working with generics, but those things that aren't actually enforced at runtime. Okay. So if I have an array list of ints, of integers or employees, it's actually really, when the code runs, it's still an array list of objects. It's still an array list of objects. Whereas if I did array list employee in C#, at runtime, it would be an array list of employees. It would be the same thing that I meant for it to be. It wouldn't change from compile time to runtime. But those things are not enforced. So because of that, we have to do some weird things with primitives. Because we don't have generics that work with primitives, we have to take our primitives and turn them into objects. Okay. So there are a few different types in Java called the sort of boxed types. And for every primitive type in C#, there is a corresponding boxed type. Okay. We call it a box because basically it's an object. So let's look at if we say we look at the integer object, basically it looks like this. Class, integer, private, int, value. And then there's a bunch of methods and constructors and whatnot. But effectively, this is what the integer class looks like. It's an integer, it's just a class that wraps a little integer variable. It puts a box around it, right? So by doing that, now I'm working with an object instead of working with the primitive int type. Does that make sense?
I thought it was just like wrapping. Like integers are wrapper classes.
Right? Wrapper, box, same thing.
Oh, okay.
Same thing. Same thing. So, but that's what the class looks like. Okay. Same thing exists for all the other types. So if I have a Boolean, the box type for that is Boolean. If I have char, is character. Byte is byte. Short is short, etc. Most of the types, they're just take the first letter and make it uppercase, and that's the boxed form of it. Okay, with the exception of character, which is car and character. But that's what they look like. All of them look like this. If you looked at the actual class, you would see there's a little variable inside that stores the type.
Yeah,
So
there isn't anything else. Or...
There's a bunch of methods and constructors for it, so you can get access to it and do some math and different things with it. So that they have quite a few methods, but really that's the only variable that's in there. They all only have a single variable of type bool, char, byte, short, int, float, double, etc. Does that make sense? Okay. So the way that works historically, if I wanted to create this, you can see how they call it wrapper right here. Wrapper, box. Both words are used. To talk about it as a wrapper or box, they're synonymous. Yes. The uppercase one is the box. Yeah. So if I look at this, I say int I primitive equals 5. So I have a nice primitive type here. And then my next line of code, I said integer I wrapper equals new integer I primitive. So this takes this 5 and box it up into an integer object. Okay, so now this is an object instead of that being a primitive. Dalton, you're kind of frowning a bit.
So, where will that box be used?
We'll get there. We'll get there. We'll get there. But you see what's happening here.
Yeah.
So I'm throwing it into a box. The other thing that happens here then, int can't be null. It's impossible for int to be null. It is possible for integer to be null because it's an object. So effectively the way we do nullables, one way to do nullables is by using these box types. Because there's not really a nullable type in Java. So instead, you might occasionally see this where they're using an integer as a nullable int.
So what would value be? Because that's an integer. I don't know.
Yeah, so like in a null integer, what is value?
Yeah.
Remember, an integer is an object. The object doesn't exist. If I say integer I wrapper equals null, there is no object. So there is no value variable.
Oh. Okay.
By the fact that there's no,
So why?
it's not null because it doesn't exist.
But why? I'm sure you're gonna get to this, but why do lists require box types and not allow primitive types?
Yeah, we'll come back to that.
Okay.
But it's because everything has to be objects when we get to generics. So this, the whole point of this is I'm taking it and putting it in an object. So now I have an object. Okay. I can also go the other way and say wrapper.intValue, and this will unbox it. So this will take it from the boxed integer type back to the primitive type. Okay, so I can box it or I can unbox it. Now, what changed in Java 5 is that these two operations can be done automatically. Okay, so if I say in Java, if I say integer x is equal to 5, that is valid Java code today.
So is it like implicitly running 5 through a constructor?
It will implicitly box it or wrap it. It will implicitly say new integer on this line. It will take the 5, create an object, and save it and save that object.
So you could use that just as if you were using an int.
Mm-hmm. Yeah, so in a lot of ways, this integer will behave as an int. Not because of this, but because of the thing I'm about to show you in the next minute. So if I have int y, I can now unbox it in a similar fashion. So that's why I can now do addition and things like that, because it gets automatically unboxed.
So what happens if you do integer x equals null?
Integer x equals null. So you see this one?
Yeah.
So if I say x equals null down here,
Yeah.
well, that's fine. Then I just have, I still have 5 here and null there.
So, but if you did integer x equals null and int y equals x, would you get null reference?
Yes. Yeah. That would result in a null reference because it's shorthand for calling in value.
Right.
Right. So I'm calling in value on this object. Object's null. So this would throw an exception right here. Which means you have to be careful with things like that. Because yes, a simple line like this can throw a null reference exception, even though it looks like it shouldn't. Okay, even though it looks like nothing should go wrong there, you can. But this is what you need to understand. So this is unboxing, automatically unboxing, and this automatically boxing. So we've got auto boxing and auto unboxing. That is really, really important when we're working with collections. When we're working with generics, these two things that they happen automatically is super important. Because A, it makes things a lot easier, but it also makes it really easy for you to create performance issues that are much harder to see. Okay. In fact, this can happen so automatically that if I pass a 5 to a function that takes an integer, it will automatically box it during the function call.
So if I have for example, just like an array list of integers, right? And I want to iterate through that, I should like write a for each with the auto unboxed version.
No, with the box version.
Okay.
Let's get to generics first, and ask that question again. But no, it's probably the reverse of what you think it should be.
Iterating through all that, don't you have to go through each, because it's like iterating through an object versus iterating through like a primitive type. Wouldn't it be faster to iterate through a primitive type rather than iterate through?
Not really.
Okay.
It actually depends on what you're doing in the body of the loop more than anything.
Right. Okay.
It has a lot more to do with the body of the loop than the actual loop. So, one of the things that means, sorry, let me talk about that real quick. So you saw what the class looked like. right? So if I have this variable here, look at this x. Well, that means whereas y, if I look at y, well, y just contains 5. But if I look at x, x doesn't actually contain 5. It contains a pointer to this object which contains 5s. Right? So there is a kind of an additional memory constraint and additional performance constraint, because every time I deal with x, I have to go down here and grab the value out. Okay.
So the left side is like a box and the right side is
This is boxed, this is unboxed.
Okay.
Right? So this is integer as an uppercase I, this is integer as a lowercase I. That's important. Because it means if I have a list, if I have an array, let's say I have an integer array of size 3, and I just have the numbers 1, 2, 3 in there, so that would look like 1, 2, 3, right? If I have integer, remember these are boxed, this is boxed, these are objects. What I'm storing in the array is not the actual values of those integers, but the references to where they live. So this would be a pointer to 1, I've got 2, I've got 3, because every value in there is an object. Right. Not a big deal, because actually it actually ends up not being too much of a big deal, because usually we end up with arrays of objects anyways. So arrays of employees, arrays of things. It's very rare that we actually have an array of integers. But if you do have an array of integers like this, that's what it looks like in memory, right? It doesn't look the same way. Okay. Which again means constraints on your performance. It's going to change your performance metrics. So this will run faster than that. Okay. Which is, I think, is where you were thinking. But
Right. Yeah.
unfortunately, what you're thinking isn't true, because you're still dealing with this.
Mm-hmm.
Okay. So, for instance, and I did say that things can get automatically boxed, unboxed. That can happen, for instance, like this. I can say I boxed it I'm going to box it manually, take 5, make an integer object out of it using an integer value of, add that to the list, or I can just say add 10, it'll automatically box it for me. Those two lines of code, both of these are being boxed automatically, adding it to the list, but one of them I'm doing explicitly and one of them is just happening automatically.
Why is it automatically boxing that?
This one?
Yeah.
Well, because array list is an array list of objects, right?
Okay,
10 is not an object.
So is an array list always objects?
Array list almost always must contain objects.
Okay.
It cannot contain primitives.
Okay. Okay.
So in order for us to add it to the list, we have to make it an object.
Mm.
So 10's got to be turned into the integer object and then added. Huh? Yeah. Okay. So let's talk about generics, because that's what all this boxing and unboxing stuff is leading into. But it just means that you have to pay, even without generics, you have to pay really close attention to your capital letters at the beginning, right? Because all lowercase Boolean is different from uppercase Boolean with a B.
Okay, they're different types. One is an object, one is a primitive. So if I want to declare a generic class in C#, and in this case I'm kind of creating a generic box. Go figure. We just talked about boxes. So I'm going to create a generic box. So I'm going to say class myBoxT. Okay. So by specifying this T here, I'm saying now that this is a generic class. Work with different types of objects, but I want there still to be some type safety. I don't just want to have this be public object box, right? Because public object box could take anything, but then I can put anything in there I want to. I want to restrict it a little bit, okay? So I'm going to say myBoxT. That gives me this generic parameter for the object. Then I can use T anywhere throughout the body of the class, and it represents the same T that I created this in. So if this is my box of employees, well then this is an employee. If this is a client or an order, if I say my box order, this is now an order box. Okay.
Is T by default representative of an object?
Any letter I use there is an object.
Right.
So when I put these T's here, when I put these what we call type arguments to the class, type arguments must always be objects in Java. That's the thing. In C#, these type arguments could be primitive types. That's not allowed in Java. I cannot say my box neat or my box car. I have to say my box, and it has to be an object. It has to be a class. Which means that when I create these generic types, I have to use the boxed versions. Does that make sense? If I want a box that contains an int, I have to say my box integer. I can't say my box int. That's because when it runs, that type checking gets compiled out. So this may be what the class looks like at runtime. I mean, when I write it, but the way that class will actually look when once the code is done and finished compiling and the code is running, it won't look like that. So class myBoxT public T box. So that's what it looks like when I'm writing the code. But when it actually runs, what it's going to turn this class into is myBox public object box. That's what's actually running. That's what's actually running in the VM. Is this. Even though that's the code I wrote, this is the code that's actually running.
And then, but you could also put anything that extends the object class as T.
Come back to that. Come back to that. But this is what's actually running. Ignoring the bound stuff, this is actually what happens. Okay? So that's very, very important to understand. Is that once I've compiled the code, this type checking goes away. Okay? Because this type checking didn't go away when I compile C# code. If I said my box employee, I was still working with my box employee when the code ran. I wasn't working with a box of objects when the code ran. Okay. So if I'm looking at this, I can create this box like so. So I can say my box integer iBox equals new my box integer. So I'm constructing a new object there. Okay. Yep.
So that's using what's your above that?
Yep, that's using this class. So you can see I'm putting a type parameter both here as what data type it is, as well as when I call the constructor, I'm also passing the type argument, passing those in both places. Now, that's what was introduced in Java 5. That is kind of cumbersome because you see I have to write the type arguments on two sides. Okay, so what was introduced in 7 is a shortcut to that. In Java 7, they said, okay, well, that's a lot of writing. Let's simplify it a bit. So rather than writing integer on both sides, you only have to write integer on the left side. So I have to specify the data type as my box integer, but I don't have to specify the data type over on the right. Yes?
So like, why wouldn't you just create that class initially as an integer? Like,
What do you
why
mean?
make it a generic class?
Because now this my box works with any type of data types. It's not specifically, it can't just work with integers. It could work with strings or employees or orders. It could work with anything. That makes sense? I'm trying to build something that can work with anything.
So like, could you also now write a my box decimal box? Like, could you have multiple from that?
There's no decimal in
Double.
double. Yeah.
Decimal.
So I could say my box, I box, and I could say my box double D box. So I could have two different boxes, but they're using the same code. It really helps with code reuse, basically, is what it comes down to. It helps with code reuse, but also it also does it in a way that's still type safe, effectively. Okay. So I can set it up like that. I can then assign a value to iBox, say iBox equals 5, or I could say pull the value out, put it in integer I, all of that works. Now, on the other hand, and this is where things about the compile time, the type checking still matter, because if I said iBox.box equals hello world, remember that this is a box of integers, it can't hold strings. So this gives me a compile time error. I can't set it to a string, or I can't set I can't set box to a string, but I also can't extract the box variable because this is an integer. I can't extract that and change that to a string. They're still incompatible types. If I had written my code like so, my box public object box, there would be no compile time errors here. This would be valid. Because remember, strings are objects. Strings are objects. So this would be valid code if box was declared as an object. Same thing here. I would have to cast here on the second line. I would have to say cast it as a string and then pull it out. But this could be valid if I didn't have these generic types. Does that make sense? So it's trying to avoid some common errors.
Oh, you're saying if you didn't put my box or T.
Yes, instead of this being T, this was object, then this would be a valid line of code. I wouldn't get a compile time error because a string is an object. Okay. I also make methods generic by adding a method parameter here. So that will then have, okay, I've declared T here, so now I can use T in there. So I'm taking an array, any array, this can work with any array, and it's going to just print all the elements of that array, regardless of what kind of array it is.
Wait, so if it's like an int, will it auto unbox integer or something like that?
It will. So if I gave it an int array,
auto box it.
Yes, it's going to auto box it. Yes. If I give this an int array, it's going to get boxed at this line of code. As I'm reading it out, it's going to automatically each one of those elements is going to automatically be boxed as I'm reading it. Okay. If I'm calling a generic method, I can call it like so. They show it in the book here as being the integer argument first. Actually, usually you put it last, so it would be print array integer I array, the other way around. So you put the generic argument second, usually when you're calling methods. Although a lot of times you don't necessarily have to tell it what kind of argument it is, because you will usually figure it out. Interfaces can also be generic by adding a type, just like I do with classes. Generic interfaces work just like generic classes. Those are very helpful because things like list, well, list is generic. List is a generic interface. Iterable is a generic interface. Comparable is a generic interface. Comparable, just to remind you, comparable is I want to compare two things and determine which one is smaller or bigger for sorting purposes or whatever. But that one is generic. So I can do things like this, say generic, an generic collection. It can store items. That's the only method it's got. And then I can say, okay, I've got a box that implements that interface. So you give me an integer, and I store it in my box. And then, well, that's it. I've implemented your interface, which is the store method. Or I can have my generic box, which can take anything. So this one only works with integers. This one can work with any type, because it's a generic class.
But the generic box and the iGeneric collection have to be of the same type.
What do you mean?
Because they're both T.
Yes. So, well, this says generic box implements the iGeneric collection, right? So if I make a generic box integer,
Well, yeah, okay.
it will implement the iGeneric collection integer interface. So it implements that version of the interface.
If you're plugging into there.
Yeah. So all this boxing really comes up because of our collections. Our generics only work with objects. So therefore, our collections have to deal with boxed data types. So, yeah. So I can also have more than one type argument. So in this case, we've got team U. So here I might say my class team U, my class integer float. So there I specify the two types separated by a comma. We're going to talk a little bit about maps eventually in here. Maps in Java, we're going to do that at some point next week. Maps do require two values, a key and a value. So they have two generic types.
So is that like a dictionary?
Yep. Maps and dictionaries are roughly the same thing with some major behavioral differences. They're the same idea. Theoretically, they're the same idea, but the way their methods are implemented is different, which means that you end up writing your code differently, dealing with them. If I want to write generic variables, I can do some of these things like this. So I can say, I've got a generic class T, so I can make a generic class, generic variable T1, of type T. I can assign null to that. That's okay because I know that T has to be an object. System.printout1.toString. That's okay because T1 has to be a string. And objects always have a toString method, so that's why that works. However, here is one of the weird ones. I can't say, oh, instance of T. That is because it's compiled out. That's because the genericism is compiled out at runtime. So this would be saying, oh, is instance of, well, this basically gets turned into object. So it doesn't work. And so this doesn't work because the genericism is compiled out. Same way this bottom one doesn't work either.
because it's compiled out. I can't say new T. That hits pretty hard. This not being able to say new T also means you can't say new T array. And both of those things become a bit of a pain. So, in some cases. Does that kind of make sense? It's, in theory, that idea that it's objects, a lot of the time that's not necessarily obvious, but it does come up enough times that you really need to understand that the generics only works with objects. Because you're going to get bitten by it enough times. Could be a thing. Okay. Another very helpful tool that I can do with generic type arguments is anytime I have a generic argument, I can say that it must extend a class. So in this case, I'm saying that T must be a subclass of A. T extends A. So this means that this means that any type that you give me also has to be a subclass or implement this other interface. That's very useful when you're working with interfaces and sort of things. For instance, a common thing to do, you might say T extends comparable, because for my method that's trying to find the maximum value or trying to sort things, I may need those objects to be comparable, right? So if I'm writing something that's finding the max, the min, or sorting, all of those places I would say T extends comparable T, because it has to be comparable with itself.
Does that just narrow down the things you could use for this?
It narrows down what T can be, what types that T can be. But it also means that I can use things now. If I say T extends comparable T, now I can call all of the methods that are on that interface. Because I know it's comparable, I now can safely call compare to and compare to objects. Without that, I can't call compare to, because I don't know if it implements the comparable interface or not. So you can also say that it has to implement more than one thing or have more than one parent class. So I can say A and I. So I might say it has to implement this interface and also have to implement the second interface, because I need it to implement both things. I can also do that same thing when I have more than one type.
So in the case of generics, does the extends keyword also do the same thing as implements?
Yeah. In this case, if I say extends, after that it can be either a class or an interface. Unlike how it works when you're declaring a class.
Yeah.
But here extends is either. Yeah. So back before Java 5, which, I mean, just for a history standpoint, my first introduction to writing Java was in Java 4 days. So I had a program that I had to convert over to Java 5 when it came out. But back in the days of pre-generics, we might write code like this. You would say array list A is the new array list. We'd go add an element, and then when we pulled it out, we had to cast. That's one of the things that we don't have to do anymore when we're dealing with generics. These casting basically doesn't, we say integer, array list integer, so we don't have to do any casting. But if you look at how this works, well, I just added a string. Now I'm trying to pull it out and cast it to an integer. Well, that's going to give me a class cast exception, because a string is not an integer. So that would throw a runtime exception. But I wouldn't know until that code runs. I couldn't, my IDE had no way of telling me that this was bad code. I'd actually run and test the program. Versus if we use generics the way we can now, and I try to say this, well, okay, so I created an array list of strings. This is a compile time error now at this point, because I know that these strings are not going to be able to cast integers. They have no common parent.
Okay? You've got integers over here, string over here, objects in between. There's no possible way to downcast a string to an integer, or vice versa, an integer to a string. So I can't get my strings into integers. So I would get a compile time error on this line of code because there's no way for it to be valid. Or if I made these type ArrayList integer, this add would be a compile time error because I told you that this was an ArrayList of integers. You can't add a string to it. So one of these two lines of code, depending on what you prefer to type as, is going to get a compile time error instead of having to wait for the runtime error. So lambdas, which is actually the last chapter in here. Yay. Lambdas are a relatively newer thing. Lambdas we have worked with last semester. We actually did a fair amount with them. You remember that lambdas are a shorthand for writing functions. And typically they're kind of write a function in one line. Okay, so what's left of the arrow is the inputs, and what's right of the arrow is the outputs. Okay. So the syntax, though, is slightly different in Java. Dash greater than instead of equals greater than. They just decided to use a different character there. Other than that, it's the same. So we do dash greater than. That gives us lambda. Officially, these are also called, sometimes in the literature, these are also called closures. And they are also named at some point. So you may hear closures, lambdas, both of those refer to this. So here I've got a short, basically int x, int y, arrow, return x plus y. Or I could shorthand that in most cases and say xy, arrow, x plus y. So if I can actually skip the return. I don't have to write the word return because it's implicit. But if I put curly braces, then I do have to write return. But putting in curly braces allows me to have a multi-line function versus this has to be one single expression. So if I need more complicated, I'll write it this, but most of the time we can get away with just writing simple functions like this. So the way that lambdas work in Java, okay? Remember in C#, how did lambdas work? They were backed by delegates, okay? Remember we had delegate types. There are no delegates in Java. They didn't add delegates. They didn't do it that way, okay? So instead, this is a shorthand for implementing an interface, is the way that we did it. So instead of having delegate types, we have interfaces still. So if I say summable interface only has one method. It takes two ints and returns an int. So I can make a quick summable by saying xy equals thing. So with that, I can implement that summable interface with a lambda. And that's what we do. So if I say summable, actually I take that back. They have it right there on the board. I should have looked for that one. So this right here, this line right here, summable s equals xy, x plus y. This actually two things. First of all, it creates a class that implements this interface. Actually, we'll go ahead and create a class. No joke. This creates a class. Okay? And whether or not you see that as another class file, you may see another class file specifically because of this one line of code. Because this does actually create a class. And it creates a class that implements this interface, which is that one method, that one combining method, and then it creates an object of that class. So this will create a class and an object. All in that line of code. That's what's happening. That's what's happening behind the scenes. So writing it this way versus actually writing a class that implements summable, creating, say, new object of that, that's the same as writing this line of code. There's no difference.
Oh, so writing that summable s equals that creates that interface? You don't have to write it?
No, we created this interface, but we automatically created a class that's a subclass of summable.
So where's the combine?
Where's the combine method? This is implementing the combine method. So this only works with interfaces that have one method. Does that make sense? I can only implement interfaces this way that have one method. Any interface that has 2 or more methods, you can't write that as a lambda. Does that make sense? So effectively, if I were kind of to write this out in long form before we had lambdas, let me go grab my text editor. Language, J, let's go to Java. Interface, so class, implements, public int combine summable. So effectively, you see this is shorthand for writing that class. That one line goes ahead and creates that class. And then if I write how this would actually look, I would see summable s is equal to new my sum. It'll be a different name. It'll be a basically a random name. Typically, it would be named like myapp.1 is actually what this would be if I change that. myapp.1. That would be the name of the class. Actually, I think it may be that, or it may be a hash. I think it's a hash. Something like that. Effectively, that's what happens behind the scene. When I create a lambda like this, it automatically creates a class that implements the interface, and then it automatically creates an object of that class. All in writing that one line of code. So this is actually what we had to do. That kind of thing was actually what we had to do in older versions of Java. Prior to, I think, Java 7 or 8, when this was reduced, when this was added, that's what we had to do. Now, the upside of this, one of the many upsides of having the syntax, a lot of the event listeners that we have, most interfaces for event listeners actually only have one method. So we can use the syntax a lot of times when we're hooking up event listeners for click events or when the text changes or things like that. So we can actually use this. We'll actually use this when we get an Android to make those lines of code a lot simpler, rather than having to write a lot of extra code like I'm doing here. There is also something I should note
It's also possible to create anonymous classes in Java. So this is one way to create this if I was going to give that class a name. The other way I could write that that's also valid Java. So I could say summable s is equal to create a class, create a new instance of this class. Actually, I don't think it includes the word new. Actually, I think it may just be like that. So class implements summable, and this is just an anonymous class.
You already use that in the MyApp class. Would that be considered a nested class?
No. So this is not a nested class. This is a anonymous class.
Even if you're using it inside like the MyApp class.
Yeah. It kind of looks like it because it is kind of nested inside, but we reserve the word nested for the context where this class is declared in the context of the class, not in the context of a method.
Okay.
So if you declare a class like this in the context of a method, we call it an inline class or an anonymous class. But if we declare it in the context class at the same level as methods, then it's a nested class. It's important because they do work differently. They do have different behaviors. So this is an anonymous or an inline class. You can see how that's a lot of code to write, right? Versus this being the same thing as that, I definitely would take this thing rather than writing all the extra code.
And one more question,
yes.
So that interface up there, summable.
Yep.
That's basically like what you said, a delegate. So you have to implement that, but it's not exactly written fully because you have to implement it in the class. So this Lambda is a faster way to do that.
Yes, this Lambda is a faster way of implementing that interface. And again, it only works with interfaces that have one method. So this is kind of how we define our delegates. We don't define the delegate, we define an interface with one method. Which is weird. But that's Java for you. They decided, let's not add a bunch to the language, let's just use the tools that we already have in a different way. So, yeah, let's not add delegates, let's not add another type for functions. We'll just say that function objects are implementations of interfaces. Which also means that these things are pretty backwards compatible. Because once you compile the code, a lot of these things like these lambdas just kind of aren't there. So you can run it on a lot of different devices. Even if they're older. There's a few common types in Java. So like binary operator is an interface that's already defined. And a binary operator takes two things and produces an object of the same type. So binary operator integer takes two integers, does something with them, and returns an integer. So in this case, I'm saying adder x plus y, but this could easily be times multiplied by modulus. Either way, it would have that, we would implement that interface. Okay, so binary operator is a common one. Unary operator, also same thing, takes in that type, returns the same type. These things exist in there and they're handy, so you don't have to create a whole bunch of interfaces just to work with the APIs. That makes sense. So you can use a lot of these functions, a lot of these interfaces that already exist. Parameters, as far as taking parameters into methods, if my function takes no parameters, I'm going to put
just a single pair of parentheses. That's to say there's no inputs. If there's only one input, then I can just put it X. It doesn't have to have parentheses. If I have more than one, then I do have to have parentheses with commas. So the only case where you get to leave off the parentheses is if there's exactly one input. But that happens often enough that it's actually probably the most common case. It takes one input or zero. So runnable is an interface that's been around for a long time. Runnable is anything you can run, and oftentimes we'll use this to start up new threads or new processes. So runnable is a function, is an interface where it takes no arguments, returns void. So it's really nice to be able to do things like this, where you can just create a runnable with a little arrow like that. Because I can't tell you how many hundreds of times I've written this right here. And this is historically how when I was doing Android professionally, this is how we wrote every single event listener, is this way, effectively, where we had to write anonymous classes. Oh yeah, so there it is, new runnable. So that's the syntax that I was missing. So this would be new summable. Sorry, it's been a while since I did this. There. So that would be what that would look like. Okay. So that's what we have for lambdas. There's a lot of common, like the ones you saw before, the unary and the binary operator. A lot of those, all those common types are in java.util.function. So that's where you can get a lot of those. I would definitely recommend that you avoid doing import java.util function.star, just because there are so many in there, and some of them have some pretty, a number of them have names that you might want to call a variable or something. So it's probably best if you say java.util function, and especially since they're more likely to add more classes to there, it's very much worth saying I only want these ones, rather than reporting the entire package. Questions? That's the big thing. So lambdas exist. They're one big difference is they're going to have a different type of arrow. And the other big thing is that they're not backed by delegates, but they're backed by interfaces. So that's the end of this quick syntax reference. So next week we'll talk a little bit about, because they didn't spend too much time in here, we would probably spend a little bit more time talking about strings and lists and maps, because those are things that you need to know a little bit more about. So we'll talk about that on Monday and Tuesday, strings, lists, and maps. Any questions more about Java syntax?